assignment to turn?
Which one? No. All right, we're back. Comp 1004. It's the winter 2017 semester. It's week 1, part 3 of our broadcast at Georgia. And we're talking about rapid application development with C# and Visual Studio. For last we left off, viewers, we talked about the perils of GitHub and sometimes how it doesn't work, as well as creating a console application here. And what does this do? Okay, so console application, really, it just pumps out stuff to the console. The console window will come up and then disappear, right? So one of the things to do when we do debugging, whether it's here in Visual Studio for Forms applications or for console applications, we can build and we can build my solution as an example. I can also run without debugging. And the way we want to do that is we can press Control F5, if I'm not wrong. If I press Control F5, and it'll run without debugging and give me something like this, right? If I don't press Control F5, if I run with debugging, it'll just run and then close right away, right? That's what the application will do. All right, so things to note about console applications. We have access to the console. And so we can do something like this. In my main, I can do something like console.WriteLine. Notice how C# gives me a little bit of code hinting, right? So hello world, right? C# also has to end in semicolons. The structure is C#. If I was going to go into C# 101, if you notice, we need to have curly braces just like we use Java and in Java. Because, of course, C# and Java are both C-influenced languages, right? They come from C, and because C uses curly braces, so does C#, so does Java. Notice how the word console here is highlighted in like a kind of a teal blue, right? The reason why is because it means that this is a class, the console class, or the method, console class, that is part of the system namespace. Think about namespaces in C# as packages in Java, right? So when I have a namespace in C#, I'm looking at a collection of classes that are usually related that I'm accessing. It's part of the system namespace. And notice on the top here, I'm actually including using statements here. Using statements include or add in these namespaces to my project. So my little few lines of code here also includes all the classes from all the other usings that I've put up there, right? They're actually automatically included. When I build and compile, only the stuff that I use is actually compiled, and the rest is ignored, okay? However, when I add all these using statements in here, right, it adds a more overhead when I compile. So if I don't need using statements, typically we remove them in the real world. For this course, please leave all your using statements alone, okay? Because they're the includes that give you functionality in your code. If you don't have a using statement, something may not work properly that works for me, okay? So console.WriteLine says, hey, take hello world, use the WriteLine method. Think about methods as functions, again, for just as a review, that are built into the console class. And this is a static class, which means I don't have to instantiate an object of this type of class console, right? I can just use the static WriteLine method without instantiating an object of this class to use it to print out hello world to the console. Let's show you what I'm talking about here. If I press start, it's just going to flash. Watch. Bam, it's flashed, right? But if I press Control F5, right, it's going to do this. Hello world. Okay, Control F5, again, is run without debugging. And what it'll do is it'll output to the console. This is what the console would look like. And then it'll output hello world to the console. Okay, why would I want to output anything to the console at all, right? Or any kind of output? It's great for debugging, right? We use the console with console applications, but we can also use a type of console or output window with Windows Forms applications. but we need to include additional classes. And we'll go back to that little hello world, and I'll show you what I'm talking about in a bit. All right, so console applications. Well, just to review what classes are, here inside my namespace, the namespace again is a container for code, right? A code container. Namespace, think about the namespace as a package. This is like the root of my application, right? I have one class that I've defined called program. I can define other classes here, right? And again, think about a class as a blueprint, right? So let's, for example, I want to make a class that's in the same file, and I use the class keyword, and I can set up a class called person. This is a very classic example. I surround when I create my class, I need to use curly braces to create the code block that encompasses my class, that is part of my class itself, right? So my person class lives and dies inside this code block right now, the scope of my person class. My person class right now has no attributes. It's just empty, an empty container, right? I need to add in a couple of things. Typical things are, what are the typical things that all classes have? Anybody? Huh? Methods. Okay, what else? What other things that all classes have? Sorry? Constructors, right? We need to do something. Constructors are initializers. That's what they do. They initialize, we use them to initialize things inside of our class. And typically, properties. There are two types of properties. Actually, there's two types of data objects inside of classes. One is properties. Typically, properties are public, okay, when I say properties. And then there's something called fields or instance variables or class variables. Those class variables or fields are private. And one of the things we want to use, one of the tenets of object-oriented design is information hiding or encapsulation. The idea that we don't want to show anything outside of our class. We don't want to reveal anything outside of the class that's unnecessary. We might have an inner working of a class, for example, different data variables that are only for that class, that are not exposed outside of the class. So we use the private keyword for that. And the way we do it is private instance variables, public properties. That's kind of our standard. So how do I create a property? The quick way to do it in C# is click or kind of type prop and then tab. If I go tab, it creates a property automatically. It's public by default. In this case, it's an integer, right? I can change it to a string. For example, I can make the property, and as I tab in, I can make the property name, right? And notice it has a built-in default getter and setter. Getters and setters, think about them as the ability for me to read and write securely into my public string name object, as an example, this property that I have. It's a location member where I can keep track of all my data. That's what I'm doing here. In this case, the name property means I'm going to, kind of keep track of the person's name. I'm going to store the person's name for each of the people, right, that I'm going to make, person objects, right? I'm going to have a name property. I can do the same thing with age. So I can do the same thing. Go down here, prop, tab, and then I'll leave it as an int, and we'll have the age property, and we'll put it in here. So there's two properties we've kind of defined. These are public properties. This is one way to define them. We'll talk about classes and objects as we move forward and how they look in C# compared to Java over the next several weeks. So don't despair if this is all new to you or if you've never seen it before. I'm going to review it. I'm going to go fast because you should have already seen it for the most part. Most people have seen it, but I'm going to review it for everyone to know. So these are public properties. Now, for my constructor, I need to make my constructor is just a method, right, that already auto triggers, if you will. It triggers as soon as an object of the type of the class is created, or what we say instantiated, right? So when an instance of the class is created, then the default constructor, right, is initialized, right, or triggered, if you will, or called. So the way we do that is we make a, first of all, the constructor should be public, right? One day when my my great VM in the sky stops. There we go, public. And it's going to return void. And if notice how it says down here, static void main, I can go public void, and the name of my constructor should be the same name as my class, right? And if I've made if I made a mistake, right? Like for example, my person class, right? It'll give me an error. Like if I think if this is wrong, if I hover over it, say person member names cannot be the same as the enclosing type. Okay. So notice that I'm kind of creating a constructor with the same name, person, right? Which is normal. If I take these two things away, public and void, right? And if I go person like this, the problem goes away, right? Public, person, but no void. Void means the return type. So notice down here where it says static void main, it means what type of method is this? It's a static method, which means I don't have to instantiate a type, right? Instantiate object of this particular class program, right? Void means what it returns, and main is the name of the method. Method, again, is just like a function. It's part of a class. So here's my person class, but now this is the default constructor. If I don't include a constructor in my class, C# will create one for me, and it'll be empty like this, right? Once I create one like this, it overrides the default constructor, just like it would be in Java, and it allows me to use this to initialize stuff. For example, I can do something like this. I can pass in the name as a requirement. So I can say something like name, right? And of course, name is a string, right? I want that as a parameter. And the other one I want is age, right? Which is an int. Okay? And then what I can do something like this. I can use the this keyword to say something like this. This.name is equal to name, very common, right? Oops, yes. And this.age, capital A, and maybe I should just rename this to the proper standard, right? Age is equal to age. Now, how does C# know that this name with a capital N is different than this name with a capital N, right? Well, the thing is, anything that I pass into a method, these two parameters, are just local variables, right? They're local, they live and die inside the method that I'm passing them to. They're copies of anything I pass in. I'm not passing by reference, I'm passing by value. So I'm passing data into my method, right? But it's being copied in. I'm not pointing to the address where it came from, okay? Again, this should be all review for you guys. Should be, right? The this keyword, other languages use self. If you're using, if you're doing something with, as an example, iOS, the new Swift language, right? Swift 3 uses self. So does Python, but it means the context of the class itself. That's what it means. So when I use the this keyword, I mean the property that belongs to this class, to the class person. So I say this name means this one. This refers to the class. So it's the class property that I'm referring to when I use this. It's an explicit use, and for sometimes what C# will say you don't need this, but we understand what you mean. In this case, because the names are the exact same for my variables, it helps to put it in, right? It'll still figure it out if I don't put it in, but it helps to make this delineation. Say this is referring to this variable name, with this name is referring to this local variable that's coming inbound into the constructor. All right, so we've got one little constructor. That's all it does. Let's make a method. We'll also make it public. And we'll make it, the method is going to return void, and it's going to be called says hello. Right? So we have a public method says hello, right? And what is it going to do? It's going to output this to the command line, right? So it's going to say console. By the way, console write line is CW. That's the shortcut. Tab. Console write line. Hello world. Okay. Now we've already have a hello world down here in our program, right? If I save, I've got two classes inside the same namespace, a class here and a class down here, right? Now, even though I've got a class. It's just a blueprint right now. It doesn't do anything. I've just defined a new object, a new data type, if you will, called person, right? With a couple of properties. One is name, the other one is age, right? And its own custom method called says hello, right? But I haven't defined an object of that class. That's the next step. And for me to define an object of that class, I'm going to do it in my driver program right here. So I'm going to just erase this one, console.writeLine, and kind of instantiate a member of that class. So I'm going to say something like this. Person is the type. We're going to say Tom, because that's me, right? Is equal to, we need to use a new keyword, new, person. And if I open up the bracket, it says, hey, guess what? IntelliSense tells me I need a name and an age. It tells me what I need because that's the custom data type that I'm creating, right? So my name would be Tom. I can put a literal in there or pass it a variable. And my age, well, we'll make it 30. How about that? It's not true. There we go. Now that when I have this, I want to use the Tom object, right? And if you notice, if I press the dot, IntelliSense, which is Microsoft's code hinting, by the way, it's TM, right? What it'll do is it'll say, hey, it'll give me some access to stuff that I've made public, right? Age, name, and says hello, right? So let's use says hello. It's a method, so I have to kind of call it with open and closing parentheses. Okay, now that I've saved that, if I press Control F5, I should see hello world, right? Because that's all I've done. And it's exactly the same. And you're going to say, well, that doesn't show me anything, Tom. You kind of did a hello world before. Cool. I like it. Let's modify my method. Instead of hello world, we'll say hello Tom, right? So we're going to kind of say hello. And then I want to do the space. We can say plus, the plus operator with a name. So I'll say this dot name. Here's something that's happening here. Okay. One, when I use this dot name is equal to name, I'm assigning. And when I assign, I use the setter of the name, right? When I use this dot name here, I'm actually getting the value of what's stored inside the name property, right? So now I'm using the getter automatically. By the way, again, this is the short form of the getter and setter, right? I know for most of you it's review. Is there anybody that doesn't understand, other than the people that I've talked to already, what I'm doing here, right? If you don't understand, you need to bone up on your object-oriented design and methodology, because this is very, very, very simple object-oriented design. Okay, so we've got our says hello, and now we're going to press Control F5, and if I do everything properly, it says hello Tom. Okay, so it's reading the data that I've put into it. Now the great thing about objects is I can make many of them, right? Tom says hello. Well, let's say we'll make another one. Person Jane is equal to a new person, which will pass in the name Jane, and she's 26 as an example, and Jane says hello. Right? Oops. Says hello. Notice that my IntelliSense didn't work that time because I went to the next line. And if I do that and I press Control, and let's add a little bit of a space to make it pretty in the console. So we'll do a console write line in there. And if I press Control F5, run without debugging, then we should have hello Tom, hello Jane, right? I'm reusing the blueprint. Both Tom and Jane are separate objects that are made from the person class, okay? So here's a great example as an intro. This is just kind of an exploratory way of looking at C#. We're going to do it again. This is not the first time or last time you're going to see classes, all right? But you should be familiar with this, the kind of way I've done it with if you've done Java. One more thing before we leave for today. Right now, my class person is inside the same file. That doesn't make any sense. I want to make my class person in its own file. How can I do this? I'm going to right-click on my project. I'm going to add. There's some quick hits here that come up in Visual Studio to add common things like classes, or you can click on New Item. If you click on New Item in Visual Studio, it'll take you to the item dialog, New Item dialog in a second when my VM responds. And when it does so, the top one is class. I can rename this one from class 1, which doesn't make any sense, to the person class, right? And press add. What it does is it creates my class right here. Notice it gives me an error because I've already defined my person class here, but that's a very simple thing. I can just take my whole person class, cut it, and put it here. And now, when I press save, my person class is in a separate file. And I don't have any errors here because both my program class and my person class are in the same namespace. If they were in a different namespace, then I would have to use a using statement to import that class into my namespace so I could utilize it. Okay. Let's run it again to make sure it works. Control F5, run without debugging. Hello, Tom, and hello, Jane. Everything works fine. Hey, this is a great place to put it up to GitHub. So I'm going to go to Team. I'm going to go to Home. I'm going to go to Changes. I've done a couple things. I've changed my person class, my person object. I've added it. See what it says add. And I've updated my program.cs file. I'm going to say something like an all-encompassing added person class, right, to GitHub. It all. I'm going to go back to Home. I'm going to go back to Sync and push. And if everything went well, then everything should be up on GitHub. So that's like kind of an exploratory way of looking at classes and objects. When we do things with Windows Forms, however, WinForms, we're going to do more stuff. And you're going to see classes and objects being used slightly differently because of the framework that is Windows Forms. Okay, slightly different than this. But for the most part, I've just demonstrated how to use a console application in C#. It's a great way to learn C# without any kind of user interface. If you're one of those kind of people, I highly recommend it. And it's a good opportunity for you to explore some of the syntax, especially if you're doing something like an algorithm. Sometimes I want to create a solution to my problem without monkeying with any user interface. I just want something to calculate something or to do something. Oftentimes, what I do is I create my class or my structure inside a console application to spit out the right result. Once I have that, I can take that almost exactly and import it into my other code. So I'm using this almost like as a playground or as an area that I can experiment when I do my code. Any questions around C# in general? I'm just kind of trying to give you a little bit of a tour. That's all it is. I don't expect you to remember everything verbatim because we're going to see this over and over again. You should be very comfortable with C# by the end of this course. Next week, be prepared. I'm going to do a little bit of assignment number 1, right? Again, I'm going to give that to you, and I should have all the assignments if I can. If I can put them all up on Blackboard, I'd like to try and do that. Again, we'll have other little exercises as well in class. I may have a bit of a quiz here and there, and if I do, I'm going to let you know about it. I won't have one next week, okay, because next week is week 2, right? If I have a quiz, and if I do multiple choice true false, it's going to be like, so what are the 3 reasons why I want to use GitHub? What are the 3 reasons? I talked about them today. What are the 3 reasons? Version control. What's the other reason? Huh? Backup. That's the worst reason, but yes. One other reason. What another reason why I want to use GitHub? Come on. Finding jobs. Okay, well, kind of collaboration, right? We want to collaborate with others or share my code with others. Those are the 3 reasons. That's the kind of question I'd ask based on what we talked about this week, right? So I'm not going to ask questions that I didn't talk about. Guys, thank you so much. We'll see you next week. 12 o'clock again, same bad time, same bad channel. Thank you.